Hello and welcome back. In section 4.1.4, we'll be looking at the definition of Riemann sums and definite integrals. So at this point, we're ready to give these systematic approximations for the area of a region a name. All right, so definition 4.1.2, Riemann sums and definite integrals. Let f of x be a function defined over an interval from a to b. An nth Riemann sum Sn for a function f of x over ab is the sum. So I'm going to take the sum of the area. So area width is going to be delta x, and height is going to be f of xk, and I'm going to add them all up from the first rectangle, which corresponds to k equals 1, to the last, which corresponds to k equals n. If you remember, our width, delta x, was the width of the whole interval, and then I divide by the number of rectangles, so I divide by n. And then xk, that I had some flexibility. I was able to take any point in the interval, and then we had a plus k minus 1 delta x, a plus k delta x. All right, so that was a bit up in the air. And then the definite integral of f over ab, that's going to be the limit as n goes to positive infinity of Sn. So the limit n goes to positive infinity of sum delta x f xk. And let me just write here, that means the number of rectangles which is n, we're sending that to infinity. That means we're increasing the number of rectangles that we're using when we're approximating the area of the region. We're increasing it and increasing it and increasing it and increasing it and sending it to infinity. And at that point, we expect our approximation not only to be very good, we expect it to be exact. We expect it to be the actual area. All right, so we will choose to only use the rightmost points of each little interval for xk. Hence, when we write this, well, delta x is still b minus a over n. I guess at this point we're just practicing, but we're going to take the right points, and so we're going to take a plus k delta x. That's going to make our life easier. All right, so let's try to apply this on the integral from 0 to 2 of 5 dx. So nothing too complicated yet. All right, so here at the bottom I have a equals 0, top I have b equals 2, and then my function f of x is just the constant 5. Let's just apply the formula to this. I have b minus a over n, so that's 2 minus 0 over n, that's 2 over n. Then xk is a plus k delta x. Again, this is a choice, but we'll fix it so everybody gets the same thing. And also we're making our lives as easy as possible. So 2 over n, so that's 2k over n. And then f of xk is going to be f of 2k over n. In this case, it's quite easy because f doesn't actually depend on the value of x, and so we just get 5. Right, so let's write what Sn is. It's going to be the summation from k equals 1 to n, delta x f of xk. So it's going to be the summation from k equals 1 to n, 2 over n times 5. So summation k equals 1 to n, 10 over n. And so really, if I spell this out, that's 10 over n plus 10 over n plus 10 over n. There's no k, so it's always the same thing, and I have n of them. And so I'm getting 10. And so when I looked at the integral from 0, 0 to 2 of 5 dx, I'm going to take the limit as n goes to positive infinity of this Sn. Well, Sn was already just 10, and so we're just going to get 10. That wasn't so bad. Let's look at what we computed. We went from 0 to 2. The height was 5. The function was pretty straightforward. That was y equals f of x. So we were looking for the area of this region. Up, 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 up. And we got 10, which is good because it is 10. All right, but this is a special case. It's pretty nice because if you notice, even if we use one rectangle, two rectangle, three rectangle, we always get 10 just because the rectangle are actually building exactly the area. All right, so now we have our definition. In the next section, I'll be linking this definition to the area, exactly what you're computing. And then in the section afterwards, so in 4.1.5, we'll look at area, and 4.1.6, we'll be learning how to compute this for functions that are a bit more involved than just 5.